Now, next is the work energy theorem. It states that the work done by a force on a body is equal to the change in its kinetic energy. It means W is equal to the change in kinetic energy. That is, work is equal to delta kinetic energy. That is change in kinetic energy. Now, how we prove this one? We have two ways. The first one, we will find out the work done as equal to the kinetic energy, which change from initial to final. That is, it is the change in kinetic energy. On the second part, we may use the alternate way. That is, if there is a change in kinetic energy, it will be equal to the work done. Now, first part, we are applying a force which increase the velocity of an object. It means we have to take an object of mass m, and the initial velocity of object is u, and the final velocity of object is v for displacement a to b. Here we have 2 point A and B, and the object having mass m. The initial velocity is u. The force is applied on this one. So when it reached up the point B, the final velocity became v. So the work done will be equal to line integration of force for every displacement element. If force applied increases the velocity of the object and it changes from u to v, then work done will be W is equal to change in velocity is from u to v, F into dx. But force is equal to mass into acceleration. So we may put the value of force as mass into acceleration. Then it is line integration from initial velocity u to v, m into a dx. Or we may write W is equal to integration u to v, and acceleration is the rate of change of velocity. That is ddt of velocity into dx. Or we may say W is equal to u to v and dv dx by dt. The rate of change of position is dx by dt. So it is velocity. So we may write here W is equal to integration u to v m v dv. The mass of the object is remain constant, so m is taken out from the integration sign. So it is integration of v dv. Now we may use the formula integration of x to the power n with respect to dx is equal to x to the power n plus 1 upon n plus 1. So here velocity having power 1. So W is equal to half m v to the power 1 plus 1 upon 1 plus 1, and the limit is from u to v. So W is equal to m v squared by 2, and the limit is u to v. Or W is equal to m, first we will write here the upper limit in place of v, so it is v squared by 2. And then we write the lower limit, that is u, so it is u squared by 2. And when we put the limit, we have to subtract them. So W is equal to half mv squared minus half mu squared. What is half mv squared? It is final kinetic energy minus initial kinetic energy. So work done is equal to change in kinetic energy. This is the first part of work energy theorem. That is, every work is equal to the change in kinetic energy. Remember here, we are getting here W is equal to half mv square minus half mu square, whatever going on in between the motion. So the force may be variable, force may be unbalanced, force may be balanced. Right? So we may take the next part, that is change in kinetic energy is equal to the net work done. For this purpose, we have to use here the change in kinetic energy is equal to work done. Second part of work energy theorem. Now here we have the kinetic energy of a moving object is half mv squared. If we write here kinetic energy as k, then it is half mv squared. Now if we differentiate both sides with respect to time, if we differentiate both sides with respect to time, then we will have d dt of kinetic energy is equal to d dt of half mv squared, or d dt of kinetic energy is equal to half m, mass is constant, it is not changing with respect to time, so we may take out differential from differentiation, or d dk by dt is equal to half m d dt may be written as d by dv of v square into dv by dt. We multiplied and divide by dv here. So dk by dt is equal to half m. Differentiation of v square is 2 v to the power 2 minus 1 dv by dt. So dk by dt is equal to 2 to cancel, v to the power 1 dv by dt. Now how we write this one now? dv by dt as acceleration and m into a is force applied on the object, and v is velocity, that is rate of change of position. So we cancel dt in both sides. We will get dk is equal to f into dx. dk is change in kinetic energy and dx is the displacement from x2 to x1 to x2, and we write this one as s, that is displacement. So change in kinetic energy is equal to force into displacement is work. Hence we proved that the change in kinetic energy is work done. In second part and in first part, we find out work done is equal to change in kinetic energy. So this is work energy theorem. Hope you like the video. In next video, we will discuss about the potential energy and other concepts. Thank you.